Hello all, welcome to our YouTube channel Smart Plus. This is an educational channel covering topics related to the electrical, automation, mechanical and automobile. We will be uploading lectures related to this domain. Please go through it and subscribe the channel. Hello friends, in earlier part, we have seen a insight to computer-aided engineering part 1. In that, we have seen what is CAE, history of CAE, history of SCAD, what are the different applications of CAE and its application related to the automobile domain. Let's move on and see a part 2 of it. So what is design process? So generally we receive a CAD or called as a geometry. Then design engineer model this 3D CAD data in a software, maybe Unigraphics or a CATIA. Then in CAE we have to mesh it with a small elements which has nodes and elements and split these components in a small parts. Then we have to apply a material to it, assign a thickness or a variable thickness or a solid components. Then we have to apply a load and a boundary conditions, and we will receive as an output a stress, displacement, strains, etc. So this is overall design and CAE integrated process. So let's see a detailed process. A CAD data is received from design team, then initial CAE model is prepared, then it is solved in a different solvers, then it is optimized, and then final design is proposed. And then here the flowchart from CAD to CAM is given. So design, then analysis, and then manufacturing. So let's go into detail of CAE. So what are the CAE process steps? So as we know, there are broadly 3 steps. First is the pre-processing, second is the analysis, third is the post-processing. So in a pre-processing, a geometry cleanup is performed, such as removal of extra duplicate surface or lines, then splitting of the geometry into small elements called as meshing. Then a CAE analyst has to assign appropriate material such as cast or steel, and in that also various grades. Then thickness to be assigned, and finally loads and its boundary conditions. After pre-processing, we have to submit this job using the specific software. And in post-processing parts, we have to see the results, its interpretation, and report out of it. So broadly, these are 3 steps of CAE. So again, a different flowchart such as geometry, material, mesh creation, loads and boundary condition, and stress results. So let's see what are the different CAE domains. So first is the durability, in which the strength of a component is checked. It is nothing but the ability of a component to sustain loads on it. Then second one is the crash. So in crash, the different crash testing of the vehicle or a frontal impact crash or a side impact crash is done to check the safety of a passenger against the life-threatening accidents. Third one is the multi-body dynamics domain (MBD), in which the loads are predicted on a components in which the vehicle models is built considering the different suspensions and loads are extracted against the input excitations. Another domain is the computational fluid dynamics, that is CFD, in which the aerodynamic force and its effects on the different components of the vehicle is studied. Then NVH, noise vibration analysis. Here the modal analysis, mode shapes, different frequencies of components, vehicles are studied. Last one is the advanced engineering department, in which composites, rubbers, co-simulation, these studies are done. Then what is the durability analysis and its different types? Let's focus on the durability domain. So basically, first one is the strength analysis. It has two parts, linear and nonlinear. In nonlinear, there are different nonlinearities such as material, contact, and geometrical. So we can see here the material itself is not a linear, that is the stress strain curve is not linear, so we have to consider non-linearity. Then contacts, these gear tooths are contacting to each other, generating a stresses. And geometrical means the component itself has the large deformation, it is not a rigid part. Then modal analysis. In modal analysis, mode shapes and frequencies of components are find out. Then another analysis is the stiffness analysis. So we can find out the stiffness in X, Y, and Z direction of each component by applying the loads and boundary conditions. Then optimization is another branch in which the different optimization is done to reduce the mass of a component or to increase the frequency. Then fatigue is the highest level of analysis in durability domain. So in fatigue, there are weld fatigue and spot fatigue. Such as weld failure is predicted using the weld fatigue techniques, and spot failure of a component is analyzed using a spot fatigue techniques. Then again we can see here there are different analyses such as strength, vibration, thermal, impact, optimization, or rigid body dynamics. Then what are the leading softwares in the CAE? So Altair is there. Then Altair is generally used for the meshing. It is HyperMesh. HyperView is for post-processing. OptiStruct for optimization, and Radius is a solver. Then MSc software is an Astral is used for the analysis purpose. ANSYS, then Abacus, Dassault System, Abacus, Dyna, LS Dyna, FemFed software is there, and Encode is there. So what are its capabilities? So these software, OptiStruct, Nastran, ANSYS, Abacus, used for the linear and nonlinear analysis, then modal and vibration analysis, dynamic analysis, buckling or heat transfer. Dyna can be used for crash analysis, and FemFed and Encode can be used for fatigue analysis. So thank you friends for attending this lecture. So as said by Einstein, everything should be made as simple as possible but not simpler. So our aim is to give these complex topics in a very simple way. So thank you friends, and we will be coming with a part 3 of this lecture. So till time, please subscribe our channel. Thank you.